Right, Venus day 153. Let's see what happens when I open this up. That's what I hoped would happen. Now I'm not going to connect it on the greenhouse side yet, but on this side, sure. The problem is I really have way too little. I need more pipes, especially the insulated pipes. And there was a very good suggestion, in one of my videos, that I really need to make this whole thing insulated, because the fuel mix can easily get very hot, and the same for the inputs, really. So all of these pipes really should be insulated, because if I have a tiny leak somewhere, things get heated up. The H2 combustor produces a lot of heat, of course. That will cause explosions. And uncontrolled explosions at that. So I will need to replace this with insulated pipes as soon as I can. The problem is I can't really right now. I just don't have the resources for that. So I need to get a lot more iron. And that's starting to get a bit trickier, honestly. Right. But I think it's time to give the basic idea of automation a try here. It's our biomass degasser. That's the centrifuge that produces biomass. That's the recycler. I don't need to name these, there's only going to be one. Pollutant filtration, H2 combustor, that's fine. Volatiles tank, yes. This is the oxygen analyzer. This is the volatiles analyzer. Gas mixer can stay a gas mixer. Oxygen pressure regulator. Kind of doesn't make sense to use a regulator anymore, does it? I will need to add another pipe analyzer for the input of the oxygen. Otherwise I just have to keep this running all the time anyway. Which is a lot of power for nothing. That's the volatiles regulator. But if I can keep this full, I will never be able to keep this full though. Right, and I should have some logic to make sure that I don't drain all the oxygen. Maybe with another... Yeah, I should control this manually. And this doesn't give me any way to check. Should I just add another pipe analyzer on the other side, maybe? Can I make another pipe analyzer? I don't have one, just the pipe meters. That's not going to be useful. I don't think I can make another. Yeah, iron, gold, electrum. Oh, maybe. The iron supply is going down very quickly. There. And I can keep it as a pressure regulator. It's slower. It will use up more power if the pressure on the input is low. But the pressure on the input shouldn't really be low. And I don't really have to let it go very low. So if the pressure here is lower than the one I want on the other side. I'm not going to pump any air anyway. And now I can connect this pipe directly to the greenhouse oxygen storage. That should work. Now for the logic. There's many different parts I need to take care of. First, all of these are shared. That's a bit annoying. Let's see. So I need a furnace, which I named what? You do have temperature, right? Biomass de gasa. You are structure furnace, of course. Now, as usual, I'm just going to go with the simple loop. Now, let's go for the first bit. I will need you. Furnace, heat ball, let's say. Whatever. No, I did the other way around, right? There. Let's get started with this part. Now, what I need to do is... No, I don't like that. This is supposed to be the... Oh! Did I do it with all the other ones? No. No, let's not worry about that. Doesn't matter. Okay. So the furnace, biomass degasser. Logic type is temperature. Batch mode doesn't matter. Let's go with average. And this is going to be really easy, so I just need to make sure that the temperature is at the target. Uh, well, let's do the functions. It's not what I want. It's also not what I want. Come on. Forgot all the functions again. I don't want branches, I want comparison. Because in this case, I just want to turn things on and off. No jumps, no loads. Oh. That's the one, right? Now, if the temperature is lower than 380, let's try. And just store it in the digital valve. There. That should work. Yeah, that's the problem. Can't really have it here because then it's not going to work unless I turn this on. Oh no, all the power is gone, of course. Let's turn you on. Yeah, but it still doesn't work. Let me put it here. I can turn this one on without any trouble. So nothing should have happened yet. Good. If I turn you on, yeah, now the logic is working. That's the problem. Okay. And as soon as it gets slightly above 100, it should stop. Should stop. Yes, good. The furnace has a different temperature than the pipeline, but this should work. So this part works nicely. The problem is I need to put it somewhere that's going to actually run. So I need the IC housing anyway, I think. You off. And turn you on. Hmm. This one also takes 100 watts. This is going to eat up a lot of power. It's just doing nothing. Yeah, the best solution to that would be to just have more power. Just leaving this on logic can be dangerous. Okay. I don't think I can make an IC housing though. There isn't going to be any of these running the whole time, fortunately. Out of iron. Or steel solder. Okay. Yeah, almost out of steel too. Of course, this is going to take 50 watts to do nothing. Not great, but oh, can't really do anything about that. I might want to be a bit stingier with the names and everything because this is already at 340 bytes. I think I only have 4 kilobytes to work with. Right. Should I just move the computer over here? Or could connect the data directly. Well, let's not worry about that right now. Okay, but the first part of the automation works. I should connect the oxygen, I think. I really should have more logic here. What am I going to run low on? Is it going to be the volatiles or the oxygen? In the long term, probably the oxygen. But the volatiles need to be handled manually, so that's also tricky. And I'm out of insulated pipes. I'll have to use normal pipes in the greenhouse, but that should be okay. No, where are you? There. I thought it's going to be closer. That's okay. This is going to work for now. I would like to have a better system for putting gases around the room. Right now I just rely on the single passive vent, which is not ideal. I think it's much better if you have multiple passive vents to spread things out over the area, or whole volume of the room. Hey. Yeah, that's a lot of extra volume. So, I'm going to be able to store a lot more oxygen. Would be nice if we had an option to use smaller and bigger pipes for the different builds. And of course that's not great for the graphics. Oh, no, I want to eat and drink. Back in a vacuum. Let's see. We have the circuit housing now, so that's good. The next step. Need to make sure that the pressure doesn't get too high. Now there should always be more volatiles than pollutants. What does that mean? Because the filtration units should take both in the same proportion, so I should keep pretty much the same ratio of volatiles and pollutant in there. That should be okay. Wait, let's see. There's there filtration here. We have on and mode. What's the mode? There's no mode. Wait. I'm not going to bother with that. I'm just going to have this. There's setting mode on, but I think that's just shared with all the other atmospheric structures, I think. Right, I will need a filter to separate the water in the H2 combustor. I forgot about that. Huh. Maybe for the first stage of the cooling, it would be nice to use the direct output from the combustor. Oh, we'll get there eventually. All right, so the second part is to make sure that the filtration unit starts picking up the output there. Start the filtration. Yeah, I don't really need to define these. I'm only going to be using them once. I do prefer to do it this way, but this is going to be complicated and I might want to save on room. Eh, you know what? If I ever connect this to the rest of the base, I'll just keep the name there, just to make sure. Okay. Now, most of the volume on the input of the filtration is going to be in the furnace, so I think it should be safe to use this. Oh yeah, but then, yeah, that was a mistake. I will need this a few times. This time I need the total pressure. And we will enable the filtration system if this is greater than 300, let's say. Should be in kPa, right? Now I'll probably add more conditions here. Mhm. Oh, yeah. Wrong. I don't think this is working correctly. That's okay. So if the pressure is high enough, we'll start filtering. Now, I need to wait, I need a way to put the biomass straight into the centrifuge or the furnace right now. I should have an opportunity to see if this part works. On. Close you. Oh yeah, didn't export it. I really don't like working with the laptop. There's some iron. Okay, not a problem. There, so this is the unprocessed biomass. I'm not going to start with the whole stack. Let's go with 10. Oh, let's go 20. So I think I'm just going to remove the chute for now. Yeah, so turn everything on. Now it's holding at 300 kPa. That should be more than enough to process the biomass. Let's see. Okay. Heating is working. That should be everything processed. I'll also need to open the furnace when it gets full enough. Hey, there's our volatiles. Good. Now, the reason I have these analyzers here is so that I can compare the temperature between the oxygen and the volatiles, because the stored volatiles are going to be warmer than the oxygen. This one already has the oxygen in, so this part should work fine. There. Should I replace the pipes at least for the fuel mixture? Okay. Now that's volatile collection. As long as I put it inside manually, the temperature is a bit high. So I don't really give it enough time to cool down. Should I also check the temperature here? Because I want this to be colder. Ah, no. Just making things complicated for no reason. The volatiles are going to be cooled down by the oxygen, which is not entirely safe, but if it's just 200 degrees, that should be okay. It's the fuel. Oh, I don't really have information about the fuel mix, do I? Combustible fuel. I don't remember at which temperature that ignites. I think it's something like 350. Highly flammable at low temperatures, yeah. It's more than nitrous. Oh, this might be interesting. Okay. So now, let's see what happens if I put a bit more in. I could also use an unloader. Don't use that very often. Oh, logic. There. Yeah, so the temperature is managed automatically. Why is the temperature here so much higher? Doesn't really get much chance to exchange. Yeah, I want to manage the temperature in the pipe instead, I think. That needs another analyzer. Or, do I get the temperature on the input as well? Should have that, right? Temperature input, yes. Well, let's use that instead of the temperature of the furnace. That should work better. I should really use shorter names. This is going to be expensive. I'm going to run out of room in the chip soon. Instead of the furnace, I'm going to take it from the filtration. And temperature. Oh, temperature input, yes. This might make it slower to heat up the furnace itself. It should be safer on the whole. It also have some way to stop everything. Yeah, there's absolutely no heat exchange between the furnace and the pipe. The problem is that the pressure is the same. Okay. I don't need to connect the input and output here, do I? That's really the fix. I think that's going to work better. Oop, stop. No, no, no. No, no. That got things a bit hot. Why is the pressure so high? Yikes. Oh, that's a problem with heat. Yeah. Wait a minute, is it the morning already? Okay, so that's it for today at least. Oh no, that's not what I wanted to do. Why are you empty? Oh, this is the output. Alright, let me fix that before I forget. Oh, this is annoying. That's a lot of insulated pipe wasted. Funny thing is that it's actually often possible to use the wrong input or output and only notice when things get exploding. Yeah. A lot of pollutant in there, that's okay. Yeah, furnace is annoying to automate. If I use the advanced furnace, that would be easier. Ah, well. Anyway. So let's switch this back to furnace. That should be better. Yes, I still want to use the pressure in the furnace to deal with this. Yeah, that should work. Transport. And let's see if this works. Pollutant is too hot to condense. Oh no. Oh, no, 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 no. That's almost exploding. That was supposed to be much colder. Right. Oh, that's a problem for another day. Bye.